This is your homework help video for 7-1 homework, adding and subtracting polynomials. Okay, one thing I want to remind you of, since we are adding and subtracting these, we're not using our exponent rules. Those exponent rules where you add the little exponent numbers and subtract them and whatnot, that only applies when you're multiplying these terms or these things, okay? We're adding these, so this goes back to the beginning of the year where you look for things that have the same last name. For example, this one, mn to the second power and mn to the second power. These guys have the same last name, so you would just add those together. You would have 3 plus 6 is 9, and you keep the same last name of mn to the second power, okay? So that's just a little quick introduction, and now we'll start on number 1. So it says find the degree of each monomial. First of all, we said in class a monomial, mono means one, so a monomial is one term. This whole thing is multiplied together, so this is considered to be one term. Okay, if you have 2 terms, it would be called a binomial. And 3 terms, a trinomial. Anything more than 3 terms would just be called a polynomial, because poly means many. So we have mono, that's 1, bi, that's 2, tri is 3, poly is just many. So usually anything more than 3. Okay, so to find the degree of a monomial, you just look to find the largest exponent in the monomial. Here it's 3, so the degree of this is 3. Now it's not because of the coefficient. That's not what I'm talking about. The coefficient has nothing to do with determining the degree. You just look for the biggest exponent in there, and that's the answer. So this is the 3rd degree. Number 3, 5xy. Well, there's a little invisible 1 on each of those. The largest exponent is 1, so this is the degree of 1. And number 5 here, 1/4 k to the 5th power. The largest exponent is that 5, 5th power. This is the degree of 5. So that's how you do those. Okay, number 7 we kind of already did as I was giving you the introduction. You're adding these, and this would be called, by the way, a binomial because there's 2 terms. This little section is a term, and that section is a term. Your terms for these are connected by a plus or subtract sign. All right? So when I combine these 2 terms, this binomial becomes a monomial with just 1 term. Look at number 9. We have negative 11 c squared d plus 12 c squared d. Since they have the exact same last name, we can combine these like terms. So I have negative 11 and positive 12. 12 minus 11 is 1. So I have 1 c squared d. And you could rewrite that without the 1 because it can be considered invisible. So our real answer would be just c squared d. Okay, number 11. We have the directions here. It says, write each polynomial in standard form. Okay, we'll talk about that. Then name each polynomial based on its degree and number of terms. Okay, so number of terms is referring to these types of words: monomial, binomial, trinomial, polynomial. That's the number of terms. The degree is based on what is the largest exponent in the entire thing. Okay, that's how you get that. So really easy if you just remember what it's talking about. Okay, so number 11, we have 7a plus 4 minus a squared. Okay, so to get it in standard form, you want to put all the stuff, the variables, the letters basically, you want to put those in alphabetical order, and you want to do it from the largest exponent down to the smallest exponent, to where your very last term will usually not even have a variable at all. Okay? So my largest exponent here is this 2 here. So I have negative a to the second power. That's my first term. Okay, and remember the negative sign's part of it. The next one would be the 7a, because I have an a again. It's got a smaller exponent of 1. So I put plus 7a. My last term will be the plus 4. That's the one that has no variables at all. So for our class's situation, we'll consider this to be standard form, but just so you know, we don't think you'll get this on a state test, but just so you know, you tend to not want a negative in front. So you could actually multiply the whole thing by a negative number and get rid of all those, but we're not gonna really worry about that right now. We're happy if you just get them in the right order. Okay, by the way, this is the standard form. What is the degree? Well, the biggest exponent is 2, so this has a degree of 2. And what is it called? Since it has 3 parts, it's called a trinomial. So this is a trinomial to the degree of 2. Number 13. Well, 13 is pretty much done for us. There's nothing to do. There's no simplifying. It's already considered to be in standard form for what is there. What is this? It's a monomial, because there's only one term. And that's to the degree of 4, because the largest exponent is a 4. There you go. Let's take a look at 15. Number 15, a pizza shop owner is monitoring the amount of cheese he uses each week. The polynomials below model the pounds of cheese ordered in the past, where P represents the number of pounds. Okay, so we have mozzarella, 6p squared plus 14p plus 125. Cheddar, 12.5p squared plus 18p plus 75. Write a polynomial that models the number of pounds of cheese that were ordered. So basically, that's a bunch of fanciness that's basically just covering up an addition problem, okay? When we add stuff, we have to only add things that are like terms. So the p squareds are both like terms, so I'm going to add those two guys. 12.5. Well, what's 12 plus 6? 12 plus 6 is 18, so 12.5 and 6 is 18.5, p squared. And then this will be 28, 29, 30, 31, 32. And then 125 plus 75 will be 200. So there is the answer. Okay, real quick before people start coming in. Adding and subtracting polynomials. This one we're adding, so I'm going to have my like terms, t squared and a minus t squared. What's t squared minus t squared? They cancel each other out, so those are gone. Minus 4t and positive 3t gives me a minus 1t, which we could just write like that. And then we have a 9 with nothing else there. We have minus t plus 9. Number 19 is a subtraction problem. So we distribute this negative sign here and here. So we end up with a minus 6z and a minus 1. 4z minus 6z is going to be negative 2z, and 7 minus 1 is going to be 6. So you end up with negative 2z plus 6. And 21 is another subtraction problem. Don't forget to distribute that negative sign. Minus 9p squared and a positive 3p squared is going to give us negative 6p squared. And then 7 minus 5, because this is a minus now, it's going to be 2. So there you go. We are not doing 22 through 24, so you don't have to worry about those. Okay, I hope the video helps, and ask questions in class.